if vector A is equal to 2i plus 4j and vector B is equal to 5i plus 2j, find vector A plus vector B. To address this, we have vector A plus vector B, and that's equal to, first bring these vectors, 2i plus 4j plus, we'll bring that of B, which is 5i. So we have this. In adding vectors, we are going to pick these components by component. So we are going to add 2i with 5i. So that will give us 2 plus 5i plus, we'll do the same thing for the j. We have 4 plus 2, and then we have this j. That's equal to 7i plus 6j. So this is how to add vectors. The question says if A is equal to 2i plus 4j and vector B is equal to 5i plus 2j, find vector A plus vector B. And we found that to be 7i plus 6j. The next question here says, given vector A equal to 5i minus 2j and vector B equal to 3i plus 2j and vector C 5i minus j, we have to find vector A plus 2b plus 3c, the second one A minus 2b minus 3c, A plus 2b minus 3c, and A minus 2b plus 3c. So for the first one, we have vector A minus 2b, vector A plus 2b plus 3c, and that's equal to, vector A as given to us in the equation is 5i minus 2j. So we're going to add that to 2b. So that will be 2 into vector B above here, we have 3i plus 2j. Then plus 3c here will be 3 into vector C up here, we have 5i minus j. So that will give us 5i minus 2j plus, by the time we open this up, we're going to have 6i plus 4j plus, we have 15i minus 3j. So that is it for this step. Then adding by components, now we are going to have 5 plus 6 plus 15. So we have 5 plus 6 plus 15 all into I. Then for the second one, we have minus 2j. That is minus 2 plus 4 minus 3. Then we'll put j outside the bracket here. So from this, 5 plus 6 is 11. 11 plus 15 we have 26. So that's equal to 26i. Then the second one we have minus 2 plus 4. That gives us plus 2. Plus 2 minus 3. That's minus 1. Minus 1 times j we have minus j. So the answer for this first one is 26i minus j. So for the second one we have vector A minus 2 times vector B minus 3c, and that's equal to the same procedure. We have 5i minus 2j minus the 2b also will be 2 into 3i plus 2j minus 3c will be 3 into 5i minus j. That's equal to, we have 5i minus 2j so next we have minus 2 times 3i is going to give us minus 6i. So let's put this minus outside the bracket. 2 times 3i we have 6i. 2 times 2j we have 4j. The same thing here. 3 times 5i we have 15i. 3 times minus j we have minus 3j. So next, at this point, we can bring the components so that we have 5 minus 6, then minus times 15, we have minus 15 also, all into I. Then for the j, we have minus 2, minus times 4, we have minus 4, then minus times minus 3, we have plus 3. This into j. So at this point we have 5 minus 6 giving us minus 1. Minus 1 minus 15 gives us minus 16. So we have minus 16i. Also coming to the j component here, we have minus 2 minus 4. That gives us minus 6. Minus 6 plus 3. That gives us minus 3. So that we have minus 3j. And the overall answer for this particular one now is minus 16i minus 3j. Up to the third question, we have a plus 2b minus 3c. So for the third one, that's the c part of this question, we have vector a plus 2 times vector b minus 3 times vector c, and that's equal to, we first bring our vector a, which is 5i minus 2j plus 2 times vector b is 2 into 3i plus 2j. Then we have minus 3 into vector c, and vector c here we have 5i minus j. So we open this further and we have 5i minus 2j plus 2 times 3i, we have 6i. 2 times 2j, we have 4j. Then we have minus 3 times 5i is 15i. 3 times minus j, we have minus 3j. So at this point, we treat this component by component. And doing that, we have 5 plus 6. 5 plus 6 minus times 15 is minus 15. We'll put I here outside the bracket. Next, we have, for the j component, minus 2 plus 4 minus times minus 3, we have plus 3. So we'll put j outside the bracket. So at this point, we have 5 plus 6 giving us 11. 11 minus 15, we have minus 4i. Minus 2 plus 4, we have plus 2. Plus 2 plus 3, we have plus 5. So that the overall answer for this C part of the equation is minus 4i plus 5j. Lastly, for the D part of this question, we have vector A minus 2 times vector B plus 3 times vector C. So, for the D part of the equation, we have vector A minus 2 times vector B plus 3 times vector C. And that's equal to vector A, again we have 5i minus 2j minus 2 into vector B, we have 3i plus 2j. Then we add 3 times vector C. Vector C, we have 5i minus j. So at this point, we have 5i minus 2j minus 2 times 3i, we have 6i plus 2 times 2j, we have 4j plus 3 times 5i, we have 15i. Then 3 times minus j, we have minus 3j. Again, adding by components, we have 5 minus 6, that is minus times 6, then plus 15, all into I. That's this plus 15 here. Then for the j component, we have minus 2 minus times plus 4, we have minus 4, plus times minus 3, we have minus 3 multiplied by j, and that's equal to 5 minus 6, we have 1 minus 1 minus 1 plus 15, we have 14. That gives us 14i. Then minus 2 minus 4 is minus 6. Minus 6 minus 3 is minus 9. Minus 9 times j, we have minus 9j. So the overall answer for this fourth one, which is vector A minus 2 times vector B plus 3 times vector C, is equal to 14i minus 9j. The next question says, given that vector OP is equal to 2i plus 3j and vector OQ is equal to minus 4i plus 5j, find QP, and then the second one, find the magnitude of vector QP. for the first one, we need to understand that this is going to be subtraction of vectors. Reason is that these are two vectors with common origin or the same initial point, and these vectors are directed towards different points. So what we are going to be doing between vector OP and vector OQ is that we are going to subtract the second from the first one. That is, if we have this vector, take this to be the first vector, and then take this to be the second vector. So if this is vector OP, and then this is vector OQ, this line here is the vector QP they are asking us to find, right? So let's take this to be our first vector, this one to be our second vector, and this to be our third vector. So when you have two vectors that have the same initial point and then pointing to different direction, we are going to subtract. So what we have here, OP is given to us as 2i plus 3i, while OQ is given to us as minus 4i plus 5j, and we are asked to find vector QP. So this vector QP now is a third vector in this case, and that third vector simply is going to be, that's vector QP, which is our third vector. The resultant vector is equal to vector OP minus vector OQ. Vector OQ, right? So vector OP, we have from our equation here, vector OQ is 2i plus 3j. So we have 2i plus 3j minus vector OQ, we have minus 4i plus 5j, minus 4i plus 5j. So with this, we can now proceed, and adding by components, we are going to have 2 minus times minus 4i, we are going to have plus 4i. So we have 2 plus 4 multiplied by I, and then we have, for the second one, we are going to have plus 3j minus times plus 5 here, which is minus 5. So we have minus 5 here, all multiplied by j. So next we are going to have 2 plus 4 giving us 6. Then 3 minus 5 is minus 2. Minus 2 times j, we have minus 2j. So that's the answer for the third vector, QP. The second part of the question here says we should find the magnitude of vector QP. The magnitude of vector QP equal to the square root of 6 square plus minus 2 square, and that's equal to the square root of 6 square is equal to 36 plus minus 2 square, we have 4, and that's equal to the square root of 40. Simplifying this further from with our knowledge of surd, this is equal to the square root of 4 times 10, and that's equal to 2 root of 10 as a final answer for this particular question.